Good morning, class. Today we are going to see about colloids and its classification. Colloids. To understand colloids, we'll take three types of solutions. Okay. One is true solution, the other one is colloids or colloidal solution itself, then suspension. Now, the first one, this is a true solution. Now, a solution is a substance which is composed of two components, solute and solvent. Now, in case of true solution, the size of the particle that is solute is less than 1 nanometer. That means which is very small. It ranges from 0 to 1 to 1 nanometer. Now, in case of suspension, the particle size is very large. That is greater than 1000 nanometer, which we can see with our naked eyes, but true solutions particles we can't see. Now, in between this, the particle size between 1 to 1000 nanometer is known as colloids or colloidal solution. The example of true solutions, we can take sugar in water or salt in water, where the particles get completely dissolved. We can see the particle. The example of suspension is sand in water. We can see the particles. And colloidal solution is starch solution. Okay. Distinction between true solution, colloidal solution and suspension. The first one, true solution is homogeneous, colloidal heterogeneous, suspension heterogeneous. Particle size as we discussed just now. In true solution 0.1 nanometer to 1 nanometer. Colloidal solution 1 nanometer to 1000 nanometer. And suspension is greater than 1000 nanometer. We can the separation of solution is not possible through ordinary filtration. For colloidal solution also it's not possible, but for suspension it's possible because the particle size is large. Similarly, ultrafiltration, true solutions we can't perform ultrafiltration, but colloidal solution we can call ultrafiltration and suspension as well. True solution is transparent, colloidal solution almost transparent, and suspension is opaque. True solutions do not settle, colloidal settle only on centrifugation, and suspension settle under the effect of gravity. True solutions diffuse rapidly, colloidal diffuse slowly, and suspension do not diffuse. Similarly, Tyndall effect, we will come across it. What is Tyndall effect? The Tyndall effect does not observe in true solutions. It can be observed in colloidal solutions and suspension. Brownian movement negligible. Colloidal solutions it occurs and suspension may occur. Visibility, not visible under even ultra microscope. It can be visible under the particle size can be visible under microscope and visible to naked eye or ultra microscope. Next, the types of colloids based on the types of phases. So we have got 4 columns. The first one is dispersed phase, means solute which get dissolves, and dispersion medium is the solvent which helps to dissolve. What is the name of the colloidal system and examples of such? Say for example, when the dispersed phase and dispersion medium is solid, we call it as solid sol. Example, minerals, gemstone, glass alloys. Similarly, when you have got solid liquid, we call it as sols simply. Example, pens, gold sol, muddy water, starch in water, protein in water, gelatin in water. Similarly, solid gas we call aerosol of solid. Example, smoke, dust storm. Liquid solid we call gels like butter, jellies, boot polish, cheese, jam. Then liquid we call emulsion, milk, medicines, shampoo, creams, emulsified oil. Liquid gas we call aerosol of liquids, fog, clouds, insecticide sprays, mist. Then gas solid we call solid foam. fume is stone, foam rubber, and gas liquid we call foam froth. Example: soda water, whipped cream, froth, soap, leather, etc. So this is the classification of colloids on the basis of the type of phases. Next, we have got a very important classification of colloids based on the affinity of dispersed phase for the dispersion medium. So first one is lyophilic colloids, which means liquid loving, and lyophobic colloids, liquid hating. Now, in case of lyophilic colloids, these are the colloidal solutions in which the particles of the dispersed phase have great affinity or love for the dispersion medium. So the colloidal solution in which the particles of the solute, we can say, have the great affinity towards the dispersion medium, that is solvent. Example, in case water acts as a dispersed phase, the lyophilic colloid is also called hydrophilic colloid. So in case if water is used as a dispersed phase, then we call it a hydrophilic colloid. Example, gums, gelatin, and starch, they are lyophilic colloids. Lyophobic colloids, these are the colloidal solution in which the particles of the dispersed phase have no affinity for the dispersion medium. Examples: colloidal solutions of gold, silver, and ferric hydroxide are lyophobic colloids. Next, classification of colloids based on the molecular size. So based on the molecular size, it is classified into three types: multimolecular, macromolecular, and associated colloids or vessels. So in case of multimolecular, particles of dispersed phase consist of aggregate of large number of atoms or small molecules having molecular size less than 1 nanometer, and the aggregate has dimension of colloidal size. In case of macromolecular colloids, in this type of colloids, individual molecules have very large size, which is of colloidal dimensions. And 3 is associated colloids or micelles. These are the substances which behave as normal electrolyte at low concentration and colloids at higher concentration. So this is the classification of three types of colloids. Now to this assignment 11. Question number 1. Write the differences between colloidal true solution and suspension. Please write down at least 5 differences. Question number 2. Give an example of the following colloidal solutions, colloidal system. One is aerosols, gels, and emulsion. And question number 3. Define the terms with 2 examples: lyophilic colloids and lyophobic colloids. Then question number 4. Classify colloids based on the molecular size. Complete this assignment and send it in my mail.